Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to discuss in our today's video is binomial theorem. Binomial theorem is a very intriguing topic in mathematics due to its wide-ranging application. So before moving forward with its use, let me ask you a question. Do you remember what is the formula for a plus b the whole square? Or a minus b the whole square? Yes, I guess most of you would have easily say the formula for this one. But what about a plus b raised to 4? Okay, this is something you can still reduce. Let's make it a little bit more complex. Can you tell what the expansion for a plus b raised to 7 or 7a minus 5b raised to 10? Now, I think it would not that simple to answer for you as you did it earlier. So here is something where the binomial theorem can come into practice. So when this power, the exponent, is difficult to find, you can apply binomial theorem to make it simpler. Yes, in fact the expansion for this expressions a plus b the whole square, a minus b the whole square, a plus b the whole cube, all these have all come through the use of the binomial theorem only. I hope that now you have understood that this video is all about the application and the use of the binomial theorem. Okay. Binomial, this word means sum or difference of two terms. Bi means two. Binomial expansion is the expansion of that sum of the two terms or the difference of the two terms. Since we have learned what literally the meaning is, now it's time for some mathematics. Okay, I'm going to take two variables here and let me assume n. Let us see the binomial expansion first. X plus y. Let x be any term, y be any term. Sum of the two terms raised to power n. This can be expanded like this. NCO, C means combinations. X raised to n, y raised to 0. So the powers will change slightly and we will end at this term. So this can be expressed as summation notation. So this is the expansion that for any positive integer n, the nth power of the sum of the two numbers may be expressed as the sum of n plus 1 term in this form. So this is in the sequence of terms. These coefficients are called the binomial coefficients NC0, NC1 till NCn. This can be defined by the formula of combinations. NCR can be expressed as n factorial over n minus r factorial times r factorial. Am I right? N factorial is called the product of the first n natural numbers from 1 to n. And I'll give you some additional information here. 0 factorial is defined as 1, just 1. This theorem, binomial theorem, is useful in algebra as well as for determining permutations and combinations and probabilities. Okay. Therefore, the binomial theorem is a quick way to multiply or expanding the binomial expression that has been raised to some exponent or power. Here I would like to show you another way to find the value of NCR. It is nothing but Pascal's triangle. Hope you're familiar with this word. To make this Pascal triangle, you must start with a pyramid of 3 ones like this. 1, 1, 1. And then you get the next row of numbers by adding the pairs of numbers from the above. 1, 1, 1 plus 1, 1. And you keep going, always adding the pair of numbers from the previous row. 3, 3, 4, 6, 4. So you keep on going in this way. For example, we can say 6C4. You can go down the row where there is a 6 after the initial 1 here. And then go over the 5th, not the 4th entry, to find the 6C4, which is nothing but 15. So 6C4, this one. Hope you're clear with this one. So as you might imagine, drawing Pascal triangle every time you have to expand a binomial would be a rather long process, especially if the binomial has a large exponent on it. Okay. But you should be familiar with this Pascal triangle. Now let us see the properties of binomial expansion. Okay. So there are n plus 1 terms in the expansion of a plus b raised to n. The first and the last term being a raised to n and b raised to n respectively. So this is the very first property of any binomial expansion. And next important property is the sum of the exponents x and y is always n. And as I have told you, the coefficients NC0, NC1, NC2 till NCn are called the binomial coefficients. If you look at the expansion, you will understand that the binomial coefficients are equidistant from the beginning and from the ending are equal. There are also few other properties of binomial expansion under the topic differentiation, but we need not those properties here. We are just focusing on the binomial theorem. Okay, now let's discuss the properties of binomial coefficients. For the sake of convenience, these coefficients NC0, NC1 till NCn, these are usually denoted by C0, C1, Cn. It is up to you. You can either use this NC0 or NC1 like that, or you can just mention C0, C1, Cn. Okay. First important property of binomial coefficients is the sum. Sum starting from 0 to n is equal to 2 raised to n. And there is another property which will give us 0. Here is the sum of the coefficients C0 plus C1, and the signs have to be alternate here. So the sum of the coefficients with alternate signs is equal to 0. And the third important property is, I'm going to collect all the even coefficients and odd coefficients, that would be equal to 2 raised to n minus 1. Hope you're clear with this property. And next property is NCR plus NCR minus 1 is equal to n plus 1 CR. Same way, we have another property for the coefficients. This is the last important property of binomial coefficients. R NCR is equal to n minus 1 CR minus 1. Hope you are clear with the properties of binomial coefficients. Here, the positive integer n is called the index of the binomial, and the number of terms in the expansion of x plus y raised to n is n plus 1. These are the key points you should remember in the topic binomial theorem. In binomial expansion, it is often asked to find the middle term or the general term. So I have listed the different terms in the binomial expansion that are covered. So first one is general term, middle term, independent term, determining a particular term. You'll be getting questions like this. Numerically greatest term, ratio of the consecutive terms or coefficients. Okay, so let us see each one by one. This is the general term in binomial expansion, x plus y raised to n. So this is nothing but t subscript r plus 1 is equal to ncr times x raised to n minus r, y raised to r. So in order to find any term required in the binomial expansion, we use this general term. We will now arrive at the general term with some examples. I'll take some examples. So in x plus y the whole power raised to n, consider the following terms to understand the relation between r and the term t. Let me show you how to find t3, t4, t5. So this is the third term. And fourth term would be, can you follow so far? This is n, nc4, x raised to 4 minus r, y raised to r. This is, okay, you can replace r by 3, and here you can replace it by 2. So you can go on like this with the other terms too. Hope you're clear with this general term. Okay. If you look at the value of r is 2 in t3 and value of r is 3 in t4. Value of r is 4, that would be in t5. That is 1 less than the term. Thus, to find any term, we will need the general term, which is t r plus 1. And the value of r is always 1 less than the general term. Hope you're clear with this one. Now let us see the powers of x and y in the general term. The index power of x in the general term is equal to the difference between the subscript n and the subscript r. The index power of y is the general term is always r. The index power of y in the general term is always r. So if you expand this one, the degree of each term is n, and the powers on x begin with n and decrease to 0. The powers of y begin with 0 and increase to n. The coefficients are always symmetric. Writing the binomial expansion in the summation formula that I gave you, that would be very compact and manageable. This general term will be considered as an independent term if the r value is equal to np over p plus q. We will be discussing examples for all these in our next video. We can see a wide range of application of this binomial theorem in mathematics. For example, we apply this in finding the remainder, finding digits of a number. So these are the most common binomial theorem applications. So if you're going to deal with the problems under this topic binomial theorem, you should know the formal statement of the theorem and the binomial formula and also its expansion. and particularly you should know the Pascal's triangle. And then you can easily understand the application of this expansion, the formula in the problems. Actually, the binomial theorem, it shows how to calculate a power of a binomial without actually multiplying it. We have discussed the basics of the binomial theorem in this video. In case if you have any query regarding this, kindly let me know.